So we're going to expand on our mole-mole ratio and converting in stoichiometry. So remember that the diagram tells you molar mass goes with grams and that we get the molar mass from the periodic table. If it's a compound, then you add those masses from the periodic table. And then 1 goes with mole. So 1 mole is the mass off the periodic table. When solving stoichiometry problems, remember to convert the given to mole first, then use the mole ratio to convert from one substance to another, and finally convert to the unit that the question is asking you. So here's our first example. We're going to need to balance our reaction. So 2 coppers, 1 copper. That gives us 2 chlorines, so we would put a 2 here. 2 hydrogens, 1 sulfur, 1 sulfur. So these coefficients are 1s. I like to list what I'm given and what I'm looking for underneath their substance in the reaction. So 0.20 moles of copper 1 chloride. Underneath copper 1 chloride, I will put 0.2 moles. React, how many grams of hydrogen sulfide would also react? So we're looking for grams of hydrogen sulfide. So underneath hydrogen sulfide, we would put a question mark in grams. That way we know what we're starting with and what we're looking for. Always start your conversion with the given value. So 0.20 moles, and that's for CuCl. We bring the unit and the substance diagonally down to the bottom. The first step is to convert your given to moles. In this problem, we're already in moles, so we can check off the first step. The second step is to use the mole ratio to convert from one substance to another substance. So we're going to set up our mole ratio. Mole of the given on the bottom, mole of the unknown, which is hydrogen sulfide, on the top. Anytime you have a mole over mole or a mole ratio, you want to use the coefficients from the balanced equation. So 2 goes in front of copper 1 chloride and 1 goes in front of hydrogen sulfide. Then when we multiply and divide, moles of CuCl will cancel out. However, before we reach for that calculator, we want our answer to be in grams. So we're going to have to do that third step and convert from moles to the unit that the question is asking for, which is grams. So we're going to set up a second part of the table, pull mole to the bottom, and what we're looking for is grams, so we can put grams on the top. Notice that the unit and the substance are not changing at the same time. Something has to remain the same. Here it was moles, here it's the substance. So now we have to think about the conversion for moles and grams. Well, we know 1 mole is equal to the mass off the periodic table. So looking at the periodic table, H2S, we have 2 hydrogens, so 2 times the mass of hydrogen, plus we have sulfur, so we're going to add the mass of sulfur from the periodic table. And we get 34.086. So when I multiply and divide, the moles of H2S cancel and we're left with grams. And that's what we're looking for, and that's the substance we're looking for. So now we can take our handy dandy calculators and we can multiply, divide, multiply, divide. So 0.2 times 1 divided by 2 times 34.086 divided by 1. And then we want the answer to have the same number of significant figures as the given value. So 0.20 has 2 significant figures, so the answer is going to have 2 significant figures, and it would be 3.4. Again, we're going to want to balance this reaction first. We have 3 oxygens and 2 oxygens. So we're going to make them both 6. 2 times 3 is 6. 3 times 2 is 6. Putting the 2 there makes 2 potassiums, so we'll have to multiply by 2. 2 chlorines, 2 chlorines. List what you're given and what you're looking for underneath the substances in the problem. How many moles of potassium chlorate? So we're looking at that polyatomic. So we're going to put question mark grams under potassium chlorate. Are decomposed to form 12.8 grams of oxygen. So under oxygen, 12.8 grams. Always start with your given value. Always bring your unit and your substance diagonally down to the bottom. Now the first step is always to convert your given to moles. And since we're in grams, we need to convert this to moles first. So we look on the periodic table. Oxygen has a mass of 16, but there are 2 of them because it's a diatomic. So 32.00 grams in 1 mole. That's what that mass is telling us. So in my conversion, 1 mole is 32 grams of oxygen. So when I multiply and divide, the grams of oxygen will cancel. Don't reach for the calculator yet. We're at moles of oxygen and we want, I'm sorry, I wrote the wrong thing here, moles of potassium chlorate. So we're going to have to use our mole ratio to go from oxygen to potassium chlorate. Bring the unit and the substance diagonally down. So moles of your given always on the bottom. Moles of the unknown always go on the top. And then anytime it's a mole ratio, you want to use the coefficients from the balanced reaction. So there are 2 potassium chlorates and 3 oxygens. Then we can take our handy dandy calculator and we can multiply, divide, multiply, divide. So 12.8 times 1 divided by 32 times 2 divided by 3 tells us we have 0.267 moles of potassium chlorate. For this reaction, to balance it, you have 2 and 2 hydrogens. That makes 4 hydrogens on the product side. So we would multiply by 2 to make 4 hydrogens. That gives you 2 oxygens and you have 2 oxygens. So consider the reaction of calcium and water. 0.15 moles of water. So under water, 0.15 moles. How many grams of calcium hydroxide? So under calcium hydroxide, we'll put our grams. Always start with your given, 0.15 moles water. Always bring your unit and your substance diagonally down. The first step to stoichiometry is to convert your given to moles. Well, our given is in moles, so we've done the first step. The second step is to use that mole ratio. So we're going to go from moles of water to moles of calcium hydroxide because that's the substance we are looking for. And then we use the coefficients, 2 waters, 1 calcium hydroxide. So when we multiply and divide, moles of water will cancel. We're at moles of calcium hydroxide. We're trying to get to grams, so we're going to set up 1 more. Bring your unit and your substance diagonally down. Grams on the top. Again, notice that we're not changing the unit and the substance at the same time. One of them has to remain the same. From the periodic table, we're going to add the masses of calcium, oxygen, and hydrogen. So calcium plus you have 2 oxygens plus 2 hydrogens. So that gives us a mass of 74.096. So that's how many grams are in 1 mole. So when I multiply and divide, the moles will cancel, giving me grams of calcium hydroxide, which is what I'm looking for. So now we can take our calculator and say 0.15 times 1 divided by 2 times 74.096 divided by 1, and we get our answer. We want two significant figures because of our given value, so we would say 5.6 grams. Last example. Ethane is being combusted, so we balance our carbons first. We put a 2 there. Balance your hydrogens next. 3. That's 4, 5, 6, 7 oxygens, so we would put 3.5. Since we can't have a 0.5, we're going to multiply all the coefficients by 2. 1 times 2 is 2, 3.5 times 2 is 7, 2 times 2 is 4, 3 times 2 is 6, so that's balanced. Then we're going to list our given and our unknown. 13 grams of ethane. How many moles of water? Always start with your given and bring that unit and substance diagonally down to the bottom. First thing we want to do is make sure our given is in moles. It's in grams right now, so that's the first thing that we're going to do is convert that to moles. Notice the substance is staying the same, but we're changing the unit. So from the periodic table, we're going to add 2 carbons and 6 hydrogens. So 2 times 12 plus 6 times 1. Gives us 30.068 for every 1 mole. When we multiply and divide, the grams will cancel. We're at moles. We're going to use our mole ratio, second step, to go from ethane to water. Moles of your given substance are always on the bottom. Moles of the unknown substance are always on the top. Then we can use the coefficients from the balanced equation. 6 waters, 2 ethanes. So when we multiply and divide, the moles will cancel. And that leaves us with moles of water, which is what we're looking for. So now we can take our calculator, 13.5 times 1 divided by 30.068 times 6 divided by 2. We want 3 significant figures, so our answer is 1.35 moles.